The last example here uses a direction it talks about bearing. So the first thing we're going to need to know is what is bearing and how do we measure bearing. So let's read this problem. Plane flies 30 miles on a bearing of 20 degrees, then 30 miles further on a bearing of 80 degrees. Find the resultant displacement vector as a distance and bearing. So when I first saw this problem, I said, what does bearing mean? So I did a little research, and it's how flight measurements are basically given. And so north has a bearing of 0 degrees. And then we can do east has a bearing of 90 degrees. South has a bearing of, 90 plus 90, 180 degrees. And we just keep rotating clockwise, and that's how we get our bearing, 270 degrees, and then back to 0 degrees or 360 degrees. So instead of starting at the 0 degrees from the x-axis, like is typical in math class, we're actually starting due north, and we're going in a clockwise manner to figure out the bearing. Okay, so back to our problem here. The plane flies 30 miles on a bearing of 20 degrees. So if I head north, I'm going to go, my vector is coming up here so that this angle is 20 degrees. So I'm going to create my triangle like this, and I'll have my y component here, my x component here. My magnitude is 30 miles. And then my second vector, call that vector B, 30 miles further on a bearing of 80 degrees. So from here, I'm actually going to go almost 90, just a little less than 90, 80 degrees this way. So this is 80 degrees. And I want to extend that so I make a nice right triangle here. So then here's my y component, my x component. And by the way, you could make your triangle coming out down in this way, but then you have to remember that this is a 10-degree angle. And then this is another 30 miles. And of course, I'm not drawn to scale. I rarely am drawn to scale, so don't let that throw you off. Okay, I have my two vectors. I have them drawn so I can find the components. Now I need to find them. So to find the x component here, I'm going to do the sine of 20 equals x over 30. Then for the y, I have the cosine of 20 equals y over 30. And I'll solve those in just a minute. Then b, I have the sine of 80 equals x over 30. And the cosine of 80 equals y over 30. All right, let me solve all those pieces here. The sine of 20 times 30, so about 10.3 approximately. Okay, then we have the cosine of 20 times 30, approximately 28.2. Then I have the sine of 80 times 30, 29.5. And then I have the cosine of 80 times 30, y is approximately 5.2. Okay, we have all of our x and y components. Now let's add them all up. X is, I'm going to have 10.3 plus 29.5, which gives me 39.8, and this is miles. So my y's, I have 28.2 plus 5.2, which gives me a total of 33.4 miles. Okay, now let's find the resulting vector. X is positive 39, so I'm going over 39, 39.8, and this is positive, so I'm going to actually go up 33. Not drawn to scale. These are miles. Okay, so my resulting vector is coming from here. So I need to know the magnitude, we'll call that M, and I'm going to need to know the angle here, but if I want to do the bearing, I'll actually need to know the angle from north. So to find the bearing, I actually want to find this angle over here. But we'll figure that out once we find the angle within the triangle. Let's call this B for bearing. Then we can find the other angle outside the triangle. So to find the magnitude, let's use Pythagorean theorem. 39.8 squared plus 33.4 squared equals the magnitude squared. It's a lot of work for one problem here, but the more you know the process, the faster you can go. 33.4 squared. Okay, square root that. So we have a magnitude of approximately 51.96 miles. And we need that direction, so we could take the tangent of our angle, which is opposite over adjacent. And we have to take the inverse of the ratio. Put in the ratio, get out the angle. So we take inverse tangent, 33.4 divided by 39.8 gives us an angle measure of 40 degrees. Let's say approximately, not exact. Okay, but this is not our bearing. This is just the 40 degrees in the triangle. Our bearing is the other half if we are to be moving from due north. So because these are complements, I know that this bearing angle is actually 50 degrees. So I have at a bearing of 50 degrees. So my magnitude was 51.96 miles at a bearing of 50 degrees. So there are 3 different vector problems using different ways to show the direction and how to find both the magnitude and direction when given 2 different vectors. Hopefully these videos are helpful for you.